I'm ready
Okay.
for those 1,000 problems.
Well, you're gonna get started. Do you guys see the lab? Let me share.
But there won't be a chance that I won't hate you.
There won't be a chance.
No, I don't think so.
That's what you say now. Okay, can you guys see it?
Yes.
Yes.
Okay, so if you guys take a look at it, the first part of it should be straightforward. You want to name the ionic compound. You're given the chemical formula, and you want to name the ionic compounds. You're going to use your polyatomic ion table. You're also going to use what you know, right? And so you'll notice that there's a lot of polyatomic ions out there. And so the goal is to first identify which one is a polyatomic ion, like in the first one. You guys see the very first one? This guy here?
Yeah.
Okay, what would be the name of that guy?
Would it be chromate?
It would be chromate. That would be, so what would be the full name of the ionic compound?
Barium chrome. Oh wait, what's
Barium.
Barium 4 chromide or chromate? Chromate.
Okay, so now this is the thing that now I get a chance to see if you guys pick this up real well. Okay, where's barium located at? Group 1, group 2, group 3, group 4, group 5? Where's it? Where's it located?
2.
Group 2, right? That's the alkaline metals. Alkaline, am I correct?
Yes, alkaline
What is
earth.
the charge on the alkaline metals?
2+.
What is it?
2+?
Say again? You said
2
hard
plus.
to- 2 plus. 2 plus. Oh, that's what you were saying. 2 plus? Does it ever change?
No.
No. Okay, so group 1 and group 2 will never change. Barium is always going to be 2 plus. So we don't have to put the Roman numeral for it. The only ones that we have to use the Roman numeral for are the ones that are transitional metals or post-transitional metals. Okay, does that make sense?
Yes.
Okay, so we don't have to put a Roman numeral there. So we would just call this what?
Barium chromate.
Piece of cake? So let's see. Let's do the last one at the bottom. What is the polyatomic ion? That's C2O4.
Oxalate.
Oxalate. Okay. Okay. And this guy, Ag2.
So that would be silver, which is in the transitional metals.
It's a transitional metal. Silver what?
Would it be silver 1 oxalate?
It would be silver 1. Okay. So now silver is a transitional metal, but 99% of all silver is going to be silver 1, unless they tell us it's something else. And it takes a lot to make it something else, like silver 2 or silver 3 or silver 4. It does happen, and we've done it before in the lab. So silver is one of those exceptions that you can get away with just saying silver oxalate.
Hey, Dr. Henry, I actually have to go right now. Can I just do it later on my own?
Yes, you can.
Okay, thank you.
Okay, no problem. Okay, so groups. So you should be able to get through most of it except for covalent compounds. We haven't really talked about that. So when we talk about covalent compounds, the way it works is these guys, you use the subscripts, or not the subscripts, the prefixes, the Greek prefixes. So for one, it's mono. For 2, it's di. For 3, it's tri. For 4, it's tetra. For 5, it's penta. For 6, it's hexa. For 7, it's hepta. For 8. So, Brianna, when you're talking about the charges for ionic compounds, that's for ionic compounds. Your ionic compounds, you know the charge of oxalate. Oxalate has a -2 charge. And then your silver would have to compensate for that oxalate. So if there's 2 silvers, then each of those silver has to have a +1 charge associated with it. So then it would be silver 1. Eight is octa. 9 is nona. And 10 is deca. 11 is undeca. 12 is dodeca. Okay, you guys get that?
Yes.
Okay,
Oh,
now how do you use it, right? So let's say I had a compound like C6O5F12. Okay, so this guy would be called
You start with hexa.
hexa, and then you give the element it is, so hexacarbon. And then how many oxygens do I have?
Penta or
Penta.
5.
Penta. Oxygen. And then how many fluorides do I have?
dodecafluoride.
Dodeca fluoride. And we use "-ide" here to let us know that it's the end of the compound. Okay. And you always put the one who is the most electronegative at the end. Okay, simple. So if I have this guy, what would I name that?
Hydrogen, oxygen, difluoride.
That's correct.
That's for 30.
What was that?
And which number is that one? Dihydrogen.
I was just making that one up. H2OF2. Okay. So do you guys see how that works? So covalent compounds are really easy to name, right? Pretty straightforward. Okay, compared to, let me erase this so you guys can see. This guy belongs to this one here. And then this guy belongs to this guy up here. Okay. Okay. And so mono is kind of like, sometimes they use it, sometimes they don't, like carbon monoxide. Carbon monoxide, what is that going to look like? What is the chemical formula for that?
CO.
Okay. Sulfur dioxide.
CO2.
SR.
SO2.
SO2.
Hmm.
Okay. Ammonia. Ammonia, you just got to know.
The NH4.
No, it's NH3, ammonium.
NH3.
Chlorine.
Cl2.
CO.
Cl2. Remember, diatomic, diatomic. Okay. You guys get it? See how it works?
Right.
Okay. So what I'd like you guys to do is do as many of you guys can do in a group, work together, compare answers, talk to each other, write it on a board. And then, let me see. And then wait till you get the acids, because we'll talk about acids on Wednesday.
Thursday, you mean?
Thursday, sorry. But I know you guys like me so much that you want to meet on Wednesday too, right? Okay.
No,
You already answered that. If I'm telling you how many of them I have, am I going to put it up higher, or are we going to put it low?
low.
That's right. So it should be a subscript, not a superscript. Sub meaning low, right? So quantity is always subscript. If we're talking about
Like
charges,
this.
that's right. Yep.
Okay.
Did you get that, Tucker?
Yeah, so are you finding that, like, where are you getting the, I was looking on the little chart that we have.
Everywhere. You have to
Okay.
look for them everywhere.
No, don't look in the chart, Tucker, because this one doesn't give you a polyatomic.
That's
Hmm.
right.
Just
So
look
in
in
this case,
Yep.
we have palladium. Palladium, what does the Roman numeral mean, Tucker?
That means that it
That's like-
is like alkaline metal.
No, it means
Well,
that
it's a part of the metal.
it's a metal, yeah, but what does that three mean?
The amount.
What was that?
You have a
The
positive.
amount.
It means it has a positive 3 charge.
It means it has a positive 3 charge,
Positive
right?
charge.
Remember, the Roman numeral means the charge on that metal. So that means that this metal here is a 3+ charge. Okay, so if that metal is a 3+ charge, how many fluorines do I need to balance it out?
We
3.
need
3.
I'll need 3 fluorines to balance it out. Okay, so then when I write the chemical formula,
And
what was that, Angie? Can I what?
I'm sorry.
Okay. Does that make sense?
Yeah.
Okay. Let's see. Now you get to do the next one. Bismuth V Chloride. So break it down for me, Chuck. Show me those skills.
Hang on.
I couldn't find bismuth.
Yeah.
Oh, here it is. It's VI.
Okay, so VI. Hang on, VI.
Go right on my screen.
Oh, hang on. Okay, so
VI. VI, not VI. VI.
oh,
V
it's
as in
VI.
boy. Yes.
Okay. Yeah, I wasn't able to find.
It's atomic number 83. Group 15 period 6.
So then it's got 5. So it's gonna have to be 5 or hang on. Where's the yeah, I'm trying to find
Okay, I'm confused. How do you make them to zero if they're both negative?
Well, bismuth isn't negative. Anytime that it has a charge, bismuth is a metal, even though it's over there, it's a post-transitional metal, meaning that it's also going to have a charge associated with it. It acts weird where it's located at.
So it's not negative, a -3 charge.
Yeah. So metals don't have a negative charge associated with it. They're always going to be positive. And so the way that the periodic table is set up, there are some post-transitional metals, meaning after transition, that are over in the non-metal area, right? Only non-metals are going to be negatively charged.
Okay, so whatever bismuth is, we'll just bounce it off of what chloride needs as well.
That's right.
Okay.
But they're letting us know, what is the charge on bismuth? What is the charge on bismuth?
5. 5.
Is that
No,
right,
so it has
Tucker?
to be +1 because of chloride, right? Or no?
No, it's
No.
+5.
isn't it like what they share?
Oh, the 5. Oh.
That's right. Remember,
That's
Ionic is not
+5.
sharing. Ionic is give and take, right? That means that they've already taken what they needed, right? And so we're just balancing it out. So remember, the Roman numeral tells us the charge, okay? So it's bismuth, 5+. So then how many chlorines or chlorides do I need to balance it out?
You need
You're
5.
gonna need 5 because they're all negative.
I'm going to need 5 chlorides.
That's what I was trying to find. Chloride.
Chloride's
So
not a
it'll be
polyatomic.
BiCO5
Tucker.
then.
It's just
Okay, so you guys got to remember, so don't use the polyatomic ion table as a crutch. You also need to use your periodic table. Where's on your periodic table, Tucker? Where is chloride
It's on the
or
Group
chlorine?
17.
in group
It's
17.
group 17, period.
Oh, okay. I see
Okay.
it.
What is going to be the charge on it?
-1.
What was that?
-1.
One.
-1, right? So it's going to have a -1 charge, right? So because it's 1 away from being a noble gas. Don't forget all the stuff you learned. Don't see y'all. You're just like, okay, I was in spring break. I know a little bit of tan, So now I don't even know anything. That's not the way it works. You got to remember it all, right?
Okay, I see it now. I see. So it's
Okay.
one away.
So anytime that I should say, most cases that you have IDE, that means that it is a monoatomic. There's an exception. Cyanide is the exception. And there are a couple of other ones, but for the most part, those are going to be your exceptions. So chloride means it's just chlorine ion, right? And that's what earlier today, that's what Paul was talking to us about. Okay. So you ready now, Tucker? We're brushing off those cobwebs. I'm gonna pick on you, right?
I think so. Yeah, I'm slowly. Okay, so for which number?
So then the final answer for that one would be Bi
+5.
Cl5. Now remember, when you write the ionic compounds, it doesn't have the charges because they balance each other out.
Okay.
Okay.
So Dr. Henry, did you do 12 or did we skip it?
Well, I skipped 12.
Okay, can I ask you, can I say that ask to
So-
verify my answer?
So you want to share how you do 12 on the board? That's what you're telling me? You're volunteering for 12.
No, that's not
No, that's what I took it. Go ahead. You can do 12. Show me 12.
Oh,
Right on my board.
Okay, so Oh, this is really fat. Oh, whatever. Okay. I'm sorry that this is so big.
We just want to make sure we can see it. That's all.
That's how I started. And then I know that this is that 4. It'll be positive, and I know that this is -2 because of where it's at. So I know I need 2 of these for this. So then my answer ends up being this.
That is correct. You didn't give anybody a chance to look at it. You're
Oh,
just so
I'm
fast.
sorry. I'm sorry.
Oops.
I don't, can I do that back? I didn't think it-
Control Z. There you go.
Dr. Henry, do
Yep.
you want us to write the charges along with the answer in there?
No. The
No,
charges-
that was just
Okay.
me. I'm sorry.
This,
I just,
this
that's
is
how I
all
just
you
did
should
it.
be writing in there. Or box, do me a favor. You can write this, right? But box the answer.
Yeah, I only wrote that on the screen because that's how my brain helps me figure out what to write
Works.
next.
Okay, thank you. Maybe, I don't know.
Okay, Tucker, you ready?
I think so.
Okay. So do number 14.
14.
Yeah.
Well, since there's no, would you just do like the MgCl?
Okay, this is read the word. Is that chloride or is it chlorate? Is that too small? Do you want me to make it bigger? He's getting old. He needs his glasses.
Oh, I see. Oh yeah. Oh yeah. Well,
So if it has an ATE at the end, what does that remind us? We just talked about it.
That whole neutral level, the one level.
No,
Polyatomic ion.
polyatomic ion. So it has an oxygen. ATE basically means there's an oxygen and a chloride together, right? Not chloride, chlorine. So where am I going to find a polyatomic ion, Tucker? I memorize them. Where am I going to find it?
on the
Their list.
Atomic shape.
Let me see if I have my sheet. Polyatomic.
hang on. So would it be CL or O3?
That's right. So
One.
write it on out. And what's the charge on it?
Negative.
A negative.
All right, so let's go. Let's do 10. All right, so would it be Mg and then
So what's going to be the charge on the Mg? Where's it located at? How far is it from being a noble gas?
oh. Would it be 5? 2?
2.
I don't
Don't give up. You can't give up because I'm gonna drought you with more of them. Okay, it's gonna be 2, right? Because if we look at our P table, right? Mg, where's Mg, buddy?
It's over, yeah.
Okay, where's the nearest noble gas? Which is
All
the
the way
nearest noble gas?
on the other should be
It's neon.
Neon, right? Neon is our nearest noble gas. 1, so if I lose 1, 2, I'm just like neon. So this guy is going to be Mg 2+, right? Because it wants to be like a noble gas. Don't forget that. That's the first thing that you guys have learned. Mg is going to be like a noble gas. Then sorry, I have 50 million windows open. There you go. Okay, so chlorate. I have the polyatomic ion table. You said that chlorate was what again?
oh the
The formula?
ClO3 negative.
ClO3 negative, right? Okay, Tucker, I have 1 negative charge and I have a 2+ charge. Is that going to equal 0?
No.
So then how many chlorates am I going to need?
Just need 1 more.
I'm going to need 1 more, right? So that means I have a total of how many?
2.
Okay, so then I'd write it as Mg parentheses because the polyatomic ion and I needed 2 of those, so subscript 2.
Okay.
Does that make sense?
Yeah, no, it's getting more. And why did you put in parentheses? Because
Because I'm saying that I'll need 2 of them, right? Of the whole thing, not just Cl, not just O, but the whole thing together.
because you got it both. Okay.
Yeah. Okay. Okay, Wilmer. Let's do one hard. Cadmium 1 for bromate.
What number is that?
Number 16. No, you can't write it that way, Brianna, because chlorate goes together, right? And you always want to put the metal first. Metal always comes first. Did you get it? You understand, Brianna? But that's a good question.
So would it, could it be CD parentheses BR BR4?
BR4?
Yeah, BRO4.
Okay. So I don't need the parentheses, you're telling me? That is correct. So in this case, you don't need the parentheses because you only have 1 per bromate, because we know that bromate per bromate is a negative charge. If you look on your polyatomic ion table, you have bromate. And you guys just learned today, which is this. You learned today that per means that I add another oxygen to that. So per bromate is BrO4. cadmium 1, that means my cadmium has a +1 charge. So I just need one of these and one of those. So I just write it like this.
Okay.
Make sense?
Yeah, it's getting a little better.
Okay.
So that one wouldn't need no parentheses, would it? Well, I was
Nope.
thinking it might have need one with like a subscript.
Nope, because there's no subscript, right, for the thing. So only if there's multiples of the bromine.
Okay.
So the answer would be CDBR.
No, the answer
BRO.
is CDBR. Excuse me. Sorry. CDBR04.
Okay.
So that's what I get for trying to shove in a sandwich, a wrap down my throat between classes or during class. Okay, let's see. Helen,
No, don't pick on me.
I'm gonna pick on you. If I don't pick on you, that means I don't like you.
Okay. Which one am I gonna do?
20.
20?
Yeah.
Okay. Mm,
I thought we did that one already.
Did we do 20?
No, we haven't done 20.
So it's DI, it's gonna be +3, right?
Okay, so what is 10? What is the chemical symbol for 10?
SN.
DI? No?
No?
Oh no.
It's SN.
SN. That is correct. SN is the symbol for 10. So what is the
10.
charge on 10?
+4?
Is it +4? What is that? What does I mean?
2?
That's right. It's a +2, right? So remember, the Roman numeral means that's the charge. Okay, so we have Si 2+. So what is the charge on oxide?
-2?
-2.
That's correct. -2. Okay, so I have a +2 and a -2. So how many of them do I need?
Just one?
Just one of each, right? So then my
So-
answer should be,
Would be SNO?
that's right,
Okay.
snow.
I got that.
Piece of cake?
Yeah, somewhat.
Somewhat. Okay.
Yeah.
Let's see. Okay, so let's do some of these covalent compounds. Egger.
Yes, sir.
Let's see. Let me clear. Come on. Let's do 27.
For 27, it would be P4S3.
That is correct. Okay, let's see. What, I had 20 people here? Samaya, are you there?
Yes.
25.
Okay. Carbon, so that would be C. Oh, do I write it on the?
You can write it, yeah.
Shoot. There I go. Okay, so C. Would be
That's correct. Okay, let's see. Darren, 30. 30.
So it would be
Okay. Is that correct? Capital A, capital S?
oh sorry, I should make that a smaller s, yeah. What? Oh,
Became possessed.
oh, there we go.
Okay. Okay,
Oh.
so
Oh, sorry, I should have
that's
fixed
all
that too.
right. Okay. Okay, let's see. Sal, 31.
31.
31.
Let's see. My little pen thingy, so I have to type it in. That'd be tetraphosphorus heptasulfide.
Tetraphosphorus heptasulfide. That is correct.
If I could spell, then it'd be correct.
Are you typing it in?
Yeah.
Okay, so I'll let you type it in. Okay, well, he's doing that. Let's see.
Oh, I spelled hepta wrong. Oh well.
Tetra, phosphorus.
Andrea, number 34. And Britt,
I just heard my name. I didn't hear the rest.
34, number 34.
34. Okay.
Yeah. Yeah, we got to work on that spelling there. Hept is H-E-P-T-A,
HEPT.
yeah. Heptasulfide. And then phosphorus, it's spelled up top on number 28 and 27 and 26.
This
Well,
is why
we know
they're
that you don't
horrible in
cheat, though.
English.
So that makes me feel better.
Of course, after you told me your ways about cheating or how you feel about it, I'm like, no.
Brittany, you're doing 36?
I'm doing, you told me to do 34.
No, I told you to do 34, but Brittany,
Oh,
I
okay.
told Brittany to do 36.
Wait, this is hard to write.
Oh, so you think it's easy, huh? You're like, God, I don't understand why his handwriting is so bad.
Oh my God. Hold on. Start over.
You can also type it.
Oh.
You hit text.
What the?
And let's see. Angie. Daisy, you're going to do 40. Okay.
Iodine. No. Oxide.
Monoxide. Tetra. Let's see. Okay, so I forgot to tell you one thing about when you're writing the name, if it's in front of oxide, you drop that letter. So you don't say nona oxide, you say non oxide. Kind of like you don't say mono oxide, we say monoxide. So you just drop the vowel in front for the oxygen. Except for dioxide, yeah. All right. Okay, good.
34.
Selenium dioxide. That is correct. Okay, piece of cake.
Piece of cake.
Okay. How do you do? Oh, was that Brianna? Oh, you're feeling frisky, huh? You want to get to the end already? Oh, these guys are called hydrates. 48 to 50. Hydrates are a combination of ionic compounds and water, right? And so the only thing is that it has water associated with it at the end. So we'll call it hydrate. So for instance, let me give you an example. I won't give you the one that's here, but let's do, we'll do okay, so you would name this like you would name it normally. So what would this guy be?
Ammonium chloroxide.
Ammonium. Is it chloroxide or is it?
Oh, all right. Is it 8?
Eight. Okay, but is it chlorate, perchlorate, chlorite, hypochlorite,
Perchlorate.
perchlorate,
Perchlorate. Yeah.
ammonium perchlorate, dihydride, hydrate.
Dinitride.
Yes. So in this case, since it has a number in front of it, this guy, I'm sorry, tri, not di. was thinking about the last one. Trihydride. So in this case, three waters. So it's, you would do this normally, and then you would call this trihydride.
You're saying trihydride, but you wrote
Trihydrate.
Okay, got it.
Sorry, I'm working on only a few hours of sleep, so. Okay, so the first one. Anybody want to volunteer? Should I volunteer?
I'll volunteer, sure.
Okay. You've been anxiously waiting that, haven't you?
Might as well try it.
Right, jump right in.
Okay, so SR is strontium dichloride, dihydrate. That's my guess. Strontium dichloride dihydrate.
Nope.
Okay.
Remember, it's an ionic compound. It's gonna behave just like an ionic compound, except for the water.
Okay, so it'd be strontium. Wait. All right. Then it'll just be strontium chloride.
Strontium chloride. That's right. Strontium chloride, and then
Dihydrate.
dihydrate. Yep. You're typing it in, or you need me to type it in?
Oh, I forgot to type it in.
Does that make sense? Brianna, since
It's chloride because chlorine is a diatomic, correct?
nope.
Oh.
It's chloride because chloride is a negative ion.
Okay.
Yep. Yeah, this is not a covalent bond. And it's 2Cl because what is the charge on strontium?
+2.
+2, right? So you're minus, you have two of them to balance it out. Make sense?
Yes.
Okay. Are there any other questions, concerns? Cash?
Are we doing the 51 through 60?
You are, but you're not doing it yet because we haven't gone over organic chemicals yet. All right.
Okay, so don't worry about that right now.
No, not right now, but I promise you we will. And you'll thank me.
Dr. Harry, so the lab is due on Monday? Or when?
On Monday.
Okay, thank you.
Yeah, the lab is due on Monday.
So for the lab, we're only going up to 50. Is that correct? Is that what I
So right
understood?
now we're going up to 50. Yes. But don't worry, we'll talk about the other parts too. So, and then you
So-
may, yes,
Have to do 51 to 60?
not yet,
Okay, not yet.
but I promise you will though, and you'll thank me.